Let's explore 4 business cases of calculating account interest. This is a pipe diagram. Light gray rectangles with dotted borders are comments containing associated data structures or fragments of Python code running inside of elements. First case is initial deposit. It starts with input port, shown as downward arrow named deposit. It sends signal into parallelograms interest rate and balance. These are storage nodes called memlets. Signal enters memlets via letter W, meaning the signal is written into memlets without producing any output. The signal also enters node getCurrentDate, filling up placeholder signal field OPERDate with today's date. Then signal enters tester shouldPush, checking signal value willCalc. This value is false for deposit port, so signal goes to no, entering memlet lastOpdate via letter W, meaning the signal is written to memlet without producing any output. As a result, rate, balance, and deposit date are stored in memlets. Second case is calculating interest amount. Signal from input port, calculate, enters memlets interest rate and balance via letter R, meaning the current memlet content is pushed out without writing anything. Pushed out signals arrive to inputs balance and rate of merger, params merger. Merger waits for signals on all its inputs before sending merged output. So far, only duration input needs a signal to trigger the merger. To do that, input signal goes into node getCurrentDate that fills placeholder signal field OPERDate. Then signal goes to tester shouldPush. This time signal field willCalc is true, so the signal goes to yes, entering memlet lastOpdate via letter P, meaning the signal gets written to the memlet and previous value is pushed out. Memlet lastOpdate stores date of previous operation, and its pushed out value goes into node getDuration, where time duration between today and date of previous operation is calculated. Then signal goes to input duration of the merger, triggering it and producing merged output signal containing balance, rate, and duration, going into input calc params of runlet interest calculator that calculates interest amount and sends result to output port interest shown as upward arrow. Third case is changing rate. We must calculate outstanding interest amount with previous rate before updating the rate. Signal from input port rate goes into memlet interest rate via letter P, writing new content and pushing previous rate into input rate of the merger. Signal goes into memlet balance via letter R, meaning nothing is written to the memlet and current balance value is pushed out to input balance of merger. As a result, previous rate and current balance are provided to inputs of merger. The third input duration is provided to the merger, the same way as in the previous case of calculating interest amount. Further flow starting from merge is also the same as previous case. Fourth case is changing balance amount, meaning that we need to calculate outstanding interest amount with previous balance before updating the balance. So, the situation reverses comparing with the previous case of changing rate. Signal from input port balance enters memlet, balance via P letter, pushing previous balance out, and writing a new balance, also entering memlet interest rate via letter R, meaning nothing is written to the memlet and current content is pushed out. The rest of the flow is the same as for previous case of changing rate.